Today is going to be really interesting. We're going to build two AI agents that operate right in the browser. The first agent will create drawings and animations for us, while the second one will navigate a website like a pro. Let's get started. Hello viewers. I'm noticing more and more projects like the browser use, where artificial intelligence operates web browsers. Even big players getting in on this too. And can a humble wizard take on such a challenge? We're going to try and answer that. In the first part, we'll explore a few concepts. First and foremost, I want my AI agent to primarily use JavaScript as a tool. In the web world, you can basically do everything with it. I'm also planning to create a universal MCP server that uses MQTT as a communication layer. This way, both agents can operate on the same MCP server, each with its own unique setup. I believe it will be an interesting experiment and could prove to be useful in future projects. When it comes to technology, both agents will be built on the OpenAI Agents SDK. They'll use tools connected through the Model Context Protocol, while these tools will communicate with the browser using the popular MQTT protocol. I know it's an unusual combo, but it's super flexible, and I'll dive into that more a bit later. In the project, we will be using Python, JavaScript, and TypeScript. If you are not familiar with one of these languages, or even any of them, don't worry. I will explain everything step by step. Additionally, apart from programming, we will focus more on architecture and concept. In this video, there's something for everyone. But enough talking, let's get to practice. The first agent will create images using the canvas element. So let's dive into what this canvas in HTML is all about. This is the code of a very simple website. I will not focus on the header right now, which contains simple definitions and styles. The body will be more relevant for us. Here, we have the definition of a canvas element. Additionally, there is a short script assigning this element to a constant in JavaScript, and then obtaining its context. Let's check out how this page appears in a web browser. Nothing special, but let's open the Web Developer Tools. I have the JavaScript console open here, and I can quickly locate my canvas element and see its size. Using JavaScript, I can easily change the height of a canvas element to 500 pixels. I can easily do the same with its width. With the CTX constant, I can draw a square. I'm doing it manually for now, but in the future my agent will handle such tasks. The initial coordinates are 100 and 100, while the height and width are also 100 and 100. I'm changing the fill color and redraw the same square, but this time I'll move it over by 50 pixels. I'm doing this exercise to show how Canvas works, and how easily it can be used with JavaScript. This is the foundation for our first agent's operation. I'll ask it to perform various tasks, and it will generate JavaScript that will run in the web browser while we watch the results. Okay, this is probably a good moment to say very briefly about MQTT for those who are not familiar with this protocol. MQTT protocol is based on a central server known as the MQTT broker, which manages so-called messages and their routing. Then we have MQTT clients connecting to the broker. These clients can be anything, like a program written in JavaScript or Python. It's also very common for smart home devices to use the MQTT protocol, as well as in the IoT world. Even an SAP server can communicate using this protocol. Each client can subscribe to one or more topics, showing its interest in messages tagged with these topics. Every client can also publish a message to a certain channel. The broker then checks who subscribes to the given topic and forwards the message to those clients. It's simple and effective, making real-time communication possible in a many-to-many setup. Let's return to our web page and see how we can use MQTT for our purposes. I'm opening a slightly expanded version of the previous Canvas example and will walk you through the changes step by step. The head section is pretty similar to before. What's new here is the added style specifically for the status field. I want to show here some details about communication with the AI agent, or more precisely, with my MCP server. Next, we have the import of a library responsible for MQTT communication. It's quite a popular library. You are already familiar with Canvas and the rest of its initiation via JavaScript. However, it gets interesting here, because we initiate a variable for the MQTT client. Then we prepare its configuration: host, port, client identifier. For now, we disable SSL. What is important are the topics we subscribe to. Next, we have a function responsible for logging to the console and displaying statuses. We will see this on the page. Next, we have a function that changes the size of the canvas. We will call it when the window is resized. At the same time, the function publishes information about the current size via MQTT. Next, we have some pretty standard steps. First, we create a function to connect to the MQTT broker. Then, we instantiate the client, set up our callbacks, specify options based on our earlier configuration, and finally, make the connection. Once connected, our callback starts. It's important to note that once we're successfully connected, we subscribe to the previously specified topics. We also publish information about the status and the current canvas size. Next, we have 2 more callbacks. And finally, the functions for publishing messages to a specific topic with a specified payload. We will use it to respond to our agent's requests, for example, about the current size of canvas. Now, we finally get to the most interesting part, the function that handles incoming messages. Our code handles 4 types of incoming messages assigned to 4 topics. The most interesting one is coding/execute, because it is responsible for executing the incoming JavaScript. The code is extracted from the JSON structure, then a function is created based on it, and it is ultimately called. Then we have coding/getSize, which does nothing but send a return message with the current size of the canvas. The situation is quite similar with getCode, which, as you can easily guess, returns the current code history. Finally, we have coding/clear, which calls a function that cleans both the canvas and the code history. Here is the function. At the end, we have just 2 things left to do. One of them is to add an event listener for when the window is resized. We've already discussed the resize canvas function. After loading the window, we connect to MQTT and perform an initial resize of the canvas. And there you have it. The code isn't very long, and honestly, it's not too complicated either. Now let's go ahead and open this page in a web browser. I want to show shortly how the agent is able to draw using Canvas. However, first we will do a small test manually using MQTT and the Mosquito client. We have a status indicating that one of the topics has been subscribed. In fact, the entire list has been subscribed, and this one was the last on the list. I'm now launching the Mosquito client to subscribe to all topics starting with coding/. This will allow me to observe all traffic between the agent and the site. Command line Mosquito also allows me to publish to the broker. My topic is coding/execute. The content needs to be JavaScript wrapped in JSON because that's how we process it on the website. This code should draw a square with a side length of 200 pixels. As you can see, it works. So at this moment, we know that our JavaScript code on the page is correct, and communication via MQTT works. This is a message that I sent using the command mosquito pub. And this is a response from my program that executed the JavaScript code. And here we have the square that I drew. Alright, since we already have the part that handles communication between the MQTT broker and our presentation layer, we'll test how the agent works in practice. After that, we'll spend some time discussing the architecture. Then, we'll dive into the code for the agent and the MCP server. But first, let's start with the presentation so we don't bore you with too much code right out of the gate. First, I'll ask the agent to draw a rectangle. I want to keep it simple so we can easily analyze the communication. We have a beautiful blue rectangle on a white background. Let's take a moment to look at the communication. First, the agent asked for the size of the canvas, to which it received a response from the web page. Then the agent provided the JavaScript code to execute. It filled the entire canvas with the white color. Next, we have calculations aimed at centering the rectangle on the canvas. Ultimately, it is drawn based on these calculations. Let's see how the agent would do if there weren't just one rectangle but 100 of them. As you can see, it managed. Since it's a continuation of the conversation, it assumed that I am interested in the blue color. Let's do something that requires some imagination, like a house. Note that the agent clears the canvas each time and retrieves its size. And there you go. We have a house, although it is a very simple drawing, and I would like to show something more complex. Therefore, I ask for the addition of details. Much better, right? It may not be perfect, but the drawing definitely leaves a better impression. But actually, the agent can do even more. Let's try asking for an animation of our solar system. This is a somewhat more difficult task and certainly requires creating more code. Without a doubt, it really helps that large language models can generate code almost flawlessly in most situations. The animation presents our 8 planets orbiting the Sun. It's a bit disappointing that there's no 9th planet, but Pluto is no longer considered as one, and the other mythical 9th planet has not yet been discovered. I'd like to request one more thing from the agent, an interactive simulation this time. Are you familiar with John Conway's Game of Life? If not, I recommend checking it out. Now, I'm asking the AI to generate the Game of Life, and I'd love to be able to use my mouse to create what's known as crawlers, which are special formations that move across the board. Not much has changed, but supposedly the code has been executed. Let's see. It does work, but instead of adding crawlers directly, I use something called a crawler generator. I might not have explained that clearly enough, but I have to say, I really like it. Alright, so we have a working agent and everything's functioning as it should. It might be helpful to talk a bit more about the architecture and show it with a visual. I also want to explain the decisions I made creating the architecture. Here's a diagram of our solution. Let's review what we already know. I've clearly explained what goes on behind the scenes in the web browser. We also understand how the browser communicates with the MQTT broker. I've also shown how the agent works, but we haven't dived into the code yet. The agent connects to GPT 4.1, which acts as its brain. Plus, it uses tools from the MCP server. This means it connects to the server via Model Context Protocol. The MCP server is designed to be universal. And naturally, it also connects to the MQTT broker using the MQTT protocol. Now, you might ask whether MQTT is even necessary, or if the whole procedure could be simplified by, for example, connecting a web browser directly to the MCP server through WebSockets. From a technical point of view, you would be right. The architecture would be simpler. But we are introducing MQTT for several reasons. The solution with MQTT will scale really well if I ever need to handle browser use on a larger scale. Plus, MQTT offers excellent observability since we can monitor all the messages. Naturally, we do need to consider security issues. Aside from that, MQTT is a standard in many different solutions. So when designing a universal MCP server, it's straightforward to adapt it like for home automation. You'll see that I don't have to change much to tailor the MCP server to a new solution or a new agent. Let's now look at the code of my agent. The first thing that may catch your eye is that it is strikingly similar to my Linux agent that installed SAP HANA. And you're right, because not much has really changed. This shows how easy it is to create solutions now that are universal. First, I import the components related to the OpenAI Agents SDK. After that, I bring in the SDK from the Model Context Protocol, focusing on the part that communicates via stdio. Then, as usual, I include the module for loading environment variables. Async I/O is crucial since the whole agent works asynchronously, adding a bit of complexity to the code. Finally, I configure my client, which I can easily switch to any model, so I'm not limited to just OpenAI. Then, loading the environment variables and setting up the conversation history array. Then, two options to enable the use of models not linked to OpenAI using the OpenAI agent's SDK. Just keep in mind, you won't have the usual observability with this setup. Here begins the main function marked as asynchronous. I use global variables related to the client. I define my MCP server, which is primarily the command that starts this server. We will move on to this when we discuss the MCP server itself. The timeout is set to 900 seconds, and this is really a remnant from the server that handles the Linux terminal, as long pauses often occur there. The further part is already directly related to the agent. And here, we have the exact and entire prompt. As you can see, it is not very long. Obviously, additional information is provided by the descriptions of tools from the MCP server, but we will get to that later. Generally, at the beginning, context is given, in which the agent is informed that it will be drawing on canvas using JavaScript. In the later part, there is information on how canvas is initialized, so that it is clear which variables can be used. At the very end, there are additional details, such as a hint on setting the background color or centering the image. Next, assigning the model and MCP server. We will leave the chat with agent function for now and proceed to the main agent loop. As you can see, the loop is very simple. Its main element is the call to chat with agent function, with the text entered by the user as a parameter and displaying the response. Additionally, the condition to end the program is checked after typing exit. The chat with agent function itself is not overly complicated. We use a global variable with the conversation history. We append to the array what the user has entered most recently. Then we invoke the agent's operation using the agent's SDK standard. The timeout is very long, but this is also inherited from the Linux agent. In the next step, we add to the conversation history what the agent returned, and also return to print it on the screen. Then we only have exception handling left. You may or may not believe, but this is essentially all the important code of the agent, because when we look further in the code, there's only resource cleanup when shutting down the agent, and in the last line, the call to our main function. And that's it. As you can see, this agent is quite simple, and the key components are really the prompt and the tools. Speaking of tools, I think it's time to dive into the MCP server. Before we move on to the MCP server code, let's take a better look at its configuration, as it is more interesting because it is supposed to be a universal server. First, we have the MQTT server URL, but the more exciting stuff comes later when we get into the tools. Here we have the name of the tool and its description. This is passed to the agent, and the agent passes it to the large language model, which decides which tools to invoke and how. Next, we have an MQTT topic to which a message should be published when the model wants to invoke the tool and the schema of this invocation, so that the client understands what to do. In our case, it is of course a web browser. The second tool was used to clean the canvas. The defined topic is coding/clear, and the data didn't really matter. The situation is a bit more interesting in the case of getCode history, because here we expect some response, and while we send the query through coding/getCode, the tool waits for any message to appear on the coding/response/code topic and sends the content back to the agent as the result of the tool's operation. So here, the definition of the response topic is crucial to enforce waiting for a response. Exactly the same situation occurs with the getSize function, because here the MCP server sends a request to the topic coding/getSize and expects a response in coding/response/size. This approach allows us to create a versatile tool that can be applied in various situations. Now, let's dive into the code for this universal MCP server. But before we get into that, I should probably show you the startup script we used in the agent. The script is straightforward, but what really stands out is that it exports the environment variable config file, which points to the configuration file we just reviewed. Then, the start script is executed by npm. With this in mind, let's go back to the universal MCP server code, which is written in TypeScript. For those unfamiliar, TypeScript is an enhanced version of JavaScript that adds static typing. This code is then compiled into JavaScript before it runs. Let's start by checking out what we're importing. First up, we've got the main part of the Context Protocol SDK. On top of that, we've included the std.io transport. This is one of the two available transport options for the MCP protocol. It's useful when we run server locally, meaning the agent and the MCP server are operating on the same computer. Next is ZOD. We use ZOD to validate parameters coming from the agent. Naturally, we also need to import MQTT since we're using that protocol. It's the same deal with the file system, which we use to load the configuration file. And since our code is asynchronous, we work with promises. Next, we have the definition of the configuration file structure, which consists of the URL to the MQTT broker and the tools. The tools are also defined strictly, with response topic as an optional parameter. Next, we have a function that loads the configuration file. It's worth noting the retrieval of the environment variable config file as the file name. Also, the function returns a configuration object after passing the JSON. Let's move on to the more interesting part, which is the main function. First, we load the configuration and then create instance of the MCP server. It's obvious that an MQTT client must also be created, based on the URL provided in the configuration. This function is an event listener for the connection. And here, upon connection, we subscribe to the necessary topics for each defined tool, if the tool has a defined response topic. Next, handling the MQTT error, or rather just displaying information. And we move on to tool configuration. In the loop, for each tool from the configuration, we first define the validator and then the tool itself. According to the design, what the tool does is publish the received payload to the configured topic. As you know, some tools are awaiting a response, so we check if the tool's configuration includes the response topic field. If it does, we set up a message handler, where we check if the incoming message is assigned to the topic we are interested in. If so, it is the response we are waiting for. Apart from sending the information back to the agent, you need to remember to clear the timeout and remove the message listener. The timeout was set earlier. And that's pretty much the whole code for this universal MCP server. At the end, there's some initialization and cleanup, but that's about it. As you can see, this part of the architecture isn't too complicated. So, creating a project like this involves coming up with the idea, assembling a few simple building blocks, and of course, doing some testing. Alright, we can go ahead and close the topic of Canvas and the drawing tool, and move on to the next step, interacting with websites. This is just the basic framework of a web application designed for recording haikus. It's essentially an interface that can be used to test the agent, to see if it understands how a website functions, even when it hasn't been pre-trained on it. The site is built using the Bootstrap framework and its standard components. You can choose various menu items here, which actually do nothing except displaying a status. We also have several elements such as a slider or a switch, or an expandable section that are not completely typical for HTML, but can certainly be altered with JavaScript. I can type in a haiku and hit save. The content will disappear, but for a moment, you'll see a confirmation message saying it was saved successfully. Let's now move on to the code and see what needs to change compared to Canvas for it to work. I'm opening the folder with the agent and the HTML code of the page. I'm interested in two files that we will be reviewing shortly. First, MQTT code 2 HTML, which is the content of the web page, and MQTT agent 2 PY, which is the agent itself. Let's first take a look at the HTML file, which is the content of our page. Here we have styles related to Bootstrap framework. As we go further down, we see the import of our MQTT library. I will not discuss in detail the part where elements that we see on the page are created. Let's proceed directly to the JavaScript. At the beginning, we have the declarations of variables you are familiar with. But further on, it's the code responsible for the fake Haiku application. So for now, I'll skip this part and move on to the part responsible for MQTT. Here are the configuration options you already know. Then the connection to MQTT, which we also discussed. There is also an event listener on Connect that subscribes to the necessary topics. Everything else is similar to what we have already discussed with Canvas. The function for publishing messages. And finally, we arrive at the most important function for handling incoming messages. We basically already know this function, but this time it handles only 2 topics, not 4 as before. There is coding/HTML, which publishes the current HTML code of the page as a response, so the agent knows what it is dealing with. There is also coding/execute, which executes the JavaScript code provided by the agent. It extracts the code from JSON. Based on this code, a new function is created, and then the function is executed. Finally, we send information about whether the call was successful. And that's it. Now we could look at the agent's code itself, but before we do that, let's first check how it works. As before, I will use 2 terminal windows. In the lower one, I will run the monitoring of all MQTT communication. This will help us understand when the agent is retrieving the HTML and when it is sending the code for execution. Meanwhile, I will run the agent itself in the upper window. We need to somehow check now if the agent sees the page and understands its content. So I ask what the purpose of the page is. This should show us whether the agent can retrieve the HTML code and analyze it. Yes, the agent downloaded the code and answered my question. I must admit that it understood my intentions quite well, although it didn't notice that it isn't actually a real website, but just a test framework. Let's check then if it will be able to write a haiku, and flip the toggle to mark the public option. Okay, it probably did it so fast that I didn't even notice when it got saved and disappeared. That's why I'm asking to do this the same way, but without saving. This time the result is visible. The toggle has been switched correctly. The haiku is written in 3 separate lines. I'll see if the agent can manage to adjust the slider. Yes, without any problems. Keep in mind that certain interface elements are invisible to us, such as a menu that is not expanded. And the agent should know the entire page based on the code, including what is hidden. It listed the menu options without any problem. Let's see if it knows what's hidden in the hints section. Yes, it knows exactly what this element is, and that it is not currently expanded. It's exactly the same text. Alright, I think that's enough of this presentation. It's clear that the agent is managing this type of page really well. Now it's worth to take a look at the code. It won't be much different from the code used by the agent handling the canvas. However, the main prompt is completely different, which might be interesting to explore. This is the agent code. You should recognize this code already, and you're right. The main difference here is that a different script is used to start the MCP server. Also, the prompt is different. Keep in mind, this prompt is really straightforward. Just a single sentence. But the agent still manages the task impressively well. The rest of the code is completely identical. So let's move on to the MCP server. We will use exactly the same MCP server because according to our assumptions, it was meant to be universal. Only the configuration will be different, adjusted to the two tools that are supported by the website. Let's start with the configuration, or maybe better with the startup script. It differs from the previous one in that it points to a different configuration file, config2.json. In the file, we have the setup for the MQTT server, along with the tools we need. The first tool is execute JavaScript, which runs code, and the second is get HTML, which retrieves it. Naturally, in the second scenario, we also specify the response topic. There's not much complexity here. We were able to completely alter the agent's functionality just by changing the main prompt and the MCP server configuration. And that was our goal from the start. I hope you enjoyed learning about the concept of JavaScript as a tool and the universal MCP server utilizing MQTT. This sets the stage for developing an agent that fully operates any web pages in the browser, although there's still a long journey ahead. So I really hope to get your feedback to see if you're genuinely interested. If this video gets 1 million likes, we'll make a second part. Just kidding, it doesn't need 1 million, but that would be awesome. Please help the algorithm so that more people can see this video. May your experiments always be successful. See you next time.